Supply pipes are both more complicated and less complicated than drainage pipes drainage and venting pipes that we just looked at. The supply pipes, the reason they're more complicated is I have both hot water and cold water in most situations. So I have these dual sets of pipes running through the building. Obviously, if I'm going to a sink, I'm going to have a connection to both the hot water and to the cold water. I'm going to want to be able to have a variety of different temperatures for different kinds of uses. But the pipes are also simpler, as I mentioned earlier, because they don't have to flow downhill. They don't have to be in a very particular location. There's a lot more freedom because they're under pressure. And so even though I have two sets, I can push them around a little bit more and I can get them around some of the other things. So like I say, they're both simpler and more complex than the drainage and vent pipes. So given that we have so much flexibility with them, you might find that the pipes are running along in the wall. They might be running in the ceiling and then dropping down in the wall. They might be running in the floor and then coming up in the wall. There's all sorts of different ways that those hot and cold supply pipes are potentially making their way around the building. And it's all dependent on a huge number of other factors that are about who owns what. Is it a condo? So therefore I want the pipes in my own space, or is it cheaper and easier to have them run in one ceiling and then drop to the space below and then go up to the space above from the same pipes? There's a whole series of different issues that would be about efficiencies and sort of logistics about where we would want those pipes to be running. But when it gets down to it, I just have to make sure that for each fixture I have the appropriate pipes getting to them. So a sink, a shower, a kitchen sink, a lavatory, a shower, all of those would all want to have both hot and cold. Obviously a WC, a water closet, a toilet would only need cold, a urinal would only need cold. You have to be careful about how you're laying out the diagram of it because you don't want to have the wrong pipe going to the urinal, say, and have hot water being wasted down through a urinal. But the gist of it is that these two pipes run all through the building and get to all the locations where there's likely to be any plumbing, any fixtures. Once those supply pipes get to that location, then there's sort of this interesting idea of the air gap. There has to be a separation between that supply pipe and the drainage system. So if you kind of think about a typical sink, I have a faucet. Let's draw one over here. So let's say I have my faucet here, and it's gonna come up. It's got the little handles. I've got the pipes coming in from the walls. There's going to be this idea of the air gap, which is the space between the bottommost outlet of the supply and the point at which the water is considered now part of the drain and waste system. And so once the water gets into that sink, you don't want it ever coming back into the supply. And so the idea of the air gap separates those. There's other systems that you can use. There's valves, we'll talk about those a little bit later. There's check valves and RPZs and lots of other different example valves. But the main system for how this separation happens is there's this idea of this air gap separator. So the two systems, the supply system and the waste system, are kind of running parallel with each other, but then never quite touch. They're always right next to each other, but there's always this little distance. And the reason for that is everybody is very, very careful to not let anything that, once it's outside of the control of the potable water in the system, you don't want it to get contaminated and somehow back into that system that could then contaminate the rest of the water supply once it gets into the system. So all of these have this sort of intricate dance between the supply and the waste. And the other thing that's sort of interesting about the supply pipes is the idea of these valves. The waste pipes are fairly simple concepts, right? There's a big pipe and water flows down and it flows downhill, and you want to get it to go as smoothly as possible and to get it to the sewer as sort of reasonably quickly as possible. You do a couple little tricky things like with the P-trap and some other stuff like that, but essentially there's really not that much going on. So it's hard to put them in because of the whole gravity thing and finding the right slopes and everything, but there's a low-tech aspect to them. The supply pipes, though, have this other thing because there's all sorts of ways that they need to be manipulated. So for one, if I have hot and cold at one fixture, I'm probably going to have a valve at that point that's going to be a sort of a mixing valve that's going to allow the hot and the cold to be joined together in some sort of fluid way so that I can very easily dial up from the cold and down from the hot and find exactly the right temperature. I might have another valve that allows me to turn the whole water system off. It's pretty rare when you want to turn off the sewer system, the drain system, but it happens all the time where you need to turn off the supply system. Maybe there's a freeze thaw and you get a crack in the pipe and suddenly the water is flowing out all over the place. It's sure handy to have a valve in some logical places where I can quickly turn off that section of pipe or maybe the entire building's worth of pipe so that I can stop the water from damaging anything, get the pipe fixed, and then move on. I might start thinking about, well, it would also be nice, well, what if we need to replace a sink in the third floor of a tenant space? It'd be nice to be able to turn off that one bathroom without turning off the whole building. So there's different examples of different types of valves and different placings of valves and why I would want them. So the supply pipes have a lot of these other things going on. So not only is there a hot and a cold, but there's all these different ways that you want to control them, whereas the waste pipes are essentially just the water goes into the fixture and then you want to get it out after the P-trap as soon as you can out to the street. There's a few other elements that will start to come into play, and I'll show some other examples in a minute. But the gist of those two ideas of the supply pipe that's kind of going wherever it needs to go for sort of logical and logistical reasons, and then the waste pipes that have to go exactly where they must go to be able to connect to the both to the fixture and find that gravity feed all the way back. That sort of play between those two is sort of one of the driving forces of how you start laying out a lot of the public spaces and buildings. This is why public bathrooms are often stacked, even bathrooms in houses are often stacked, is that it just makes that so much easier to have all of those things in sort of a logical order and all contained in one zone, so you don't have a lot of extra friction, you don't have a lot of extra complication, you don't have a lot of extra valving or other elements that start to create sort of complication. So this, even though it seems like a fairly innocuous idea, the placement of, say, a couple of bathrooms, it actually can become a sort of early on design driver, not a driver in the sense of kind of the conceptual idea, but sort of you often will place it fairly early on so that you can start getting a clear idea of where those utility lines are going to go, because there's only so many locations that those waste pipes can go. And so that will be one of those things that starts to impact design drawings very quickly. And then, like I said, it's that dance between the supply and the waste pipes from there, sort of making sure it all makes sort of logical sense.